Good afternoon, class. Here's the second part of the final exam review, covering from 1.6 to 5.4. Here's the pledge. As always, we pledge not to get any help when we take the exam. So let's finish it off by looking at some more examples, all of which have been discussed in previous lectures and practices. So the integral of ln x quantity squared over x dx, you use the u substitution. Always ln x is a choice of u. The derivative is 1 over x, which makes the u 1 over x dx. So we are going to rewrite it. So it becomes clear that it's the integral of u squared du. Therefore, we are going to use the power rule, 1/3 u cubed plus a constant, replace it, and we are done. What happens when we have a fractional format? First and foremost, we want to simplify if we can't. The denominator is a choice of u. And notice the derivative of the bottom is the top. Therefore, the top times the x becomes du. So u is e to the power of x plus e to the power minus x, and du is e to the power of x minus e to the power minus x dx. We are going to rewrite this by putting dx next to the numerator. Therefore, we are dealing with the integral of du over u, which becomes a natural log and a constant. We replace the u, and the final answer ln of e to the power of x plus e to the power minus x plus a constant. By the way, this expression is positive. You could lose the absolute value, replace it with the parentheses. If you have doubts, don't do that. All right, let's continue. When we look at d theta, that means the answer for 5 must be 5 theta when you integrate or differentiate. Cosine, the derivative is negative sign. The integral is positive. Okay, so we are going to write plus 2 sine theta and a constant. Anytime e is involved, the exponent is a choice of u. And if u is x to the power of 5 minus 2, then du dx is 5x to the power of 4, which makes du 5x to the power of 4 dx. So we are going to move x to the power of 4 next to dx. So it becomes most everything is in order. What is missing is 5. And in most texts, they solve for dx. However, because 5 is a number, the easiest way would be to plug in 5 and undo it with 1/5. Now notice this is e to the power of u, this is du, which gives you simply e to the power of u. So 1/5 e to the power of u and a constant. Reversing the substitution gives us 1/5 e to the power of x to the power of 5 minus 2 plus a constant, and we are done. Again, what happens when ln x is involved? That is the choice of u. As you know, the derivative is 1 over x plus 1 times 1, which makes du 1 over x plus 1 dx. So we are going to rewrite this in this format that it becomes clear we are dealing with u du, and you can integrate this as 1/2 u squared, replace the u with ln x plus 1, go to the original limits, or if I plug in 0 here, 0 instead of x, I get ln of 1, which is 0. If I plug it in here, I get ln of 2, and I'm going to keep it as ln 2 because that's an exact answer. So 1/2, you plug in the top, it's ln 2 to the second power. The bottom gives you 0, doesn't do anything, and we are done. When sinusoidal functions are involved, if the argument is a function of x, that's a choice of u. The derivative is 2x, which makes du 2x dx. So we're going to move things around, and therefore, we notice everything is in order. We can solve for dx or simply plug in 2 and 1/2 because the product is 1. So we are dealing with half of the integral of sine u du. The integral of sine is negative cosine. And minus 1/2 cosine u plus a constant, replace it, and the final answer, negative 1/2 cosine x squared plus c, and we are done. When we have sine and cosine, both of them, Remember, the derivative of sine is cosine. The derivative of cosine is negative sine. The one with the exponent is the choice of u without the exponent. That means sine x. The derivative is cosine, therefore du is cosine x dx. So we are looking at u squared du. Power rule gives us 1/3 u cubed and a constant. Replace it, you're done. So what happens when cosine has the exponent, then cosine is the choice of u. Its derivative is negative sine x, therefore du is negative sine x dx. So over here, we basically have a negative sign missing. So we can put a negative in, negative out, because -1 times -1 is +1. So we have negative integral of u to the power of 20 du, using again the power rule, -1/21 u to the power of 21 and a constant. Reversing the substitution gives us the final answer, -1/21 cosine to the power of 21x plus a constant. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Rounded to 1 decimal. So what we are dealing with here is the derivative of some function. We're going to say the length L of x. So we let L of x represent the length of fish at age x. Then the growth rate, that means this derivative L prime or dl dx is 29 e to the power minus x centimeters per year with the initial value L of 0 equals. So the amount of increase follows the FTC fundamental theorem of calculus, which is also known as the net change theorem. So from 0 to 4, because it's 4 years, that represents the amount of increase if we take the derivative. So the increase in length after the 4 years is the integral of 0 to 4, 29 e to the power minus x dx. So the derivative and integral is the same. This makes it minus. So minus 29 e to the power minus x from 0 to 4, you plug in. You work it out. And that's the amount of increase with the initial value being 1. We're going to add the 2. And because they asked for 1 decimal, 4 next to the 6 goes up to 5, about 29.5 centimeters. However, we can find L of x in general, which means we're going to integrate this. The answer was this. We're going to add a constant with the initial value. This is the general solution. Initial value will help us find the value of C. So let's plug in, replace the x with 0, L of x or y with 1. E to the power of 0 is 1, so minus 29 plus what number? Is 1, is number 30. And now all you have to do, plug in 4, L of 4, and you get exactly the same answer. The advantage, again, as I mentioned before, is that if they ask you for the length after 5 years, 6 years, 7 years, all you have to do in this formula, replace it accordingly. The distance in meters of an object from a starting point is given by S of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity of the object? From 2 to 4 seconds. This is the average velocity, total distance over total time, or S of t sub 2, which is S of 4, minus S of t sub 1, which is S of 2 over 4 minus 2. So into this, we replace the t with 4, minus we replace it with 2. And simplification will result in 52 minus 38 over 2, or 7 meters per second. We're done elementary algebra. Now, what is the instantaneous velocity and acceleration of the object? What is the velocity and acceleration after 6 seconds? We're talking about this part, calculus. So as you know, v is s prime, so it makes it 4t minus 5. After 6 seconds, 4 times 6, 24 minus 5 is 19 meters per second. 19 meters per second. Now, as far as acceleration is concerned, acceleration is the second derivative of the position function. A of t is v prime or s double prime. If I differentiate this again, I get 4. The units are meters per square second because this is dv dt. The units for the velocity is meters per second. For t is seconds becomes meters per squared second. And after 6 seconds or 10 seconds or any time makes no difference because it's independent of t. So it's always 4 meters per square second. When does the object reach a velocity of 31? The velocity for t minus 5 equals 31. So we get 36 divided by 4, 9 seconds. We're going to use differentials, and we want to use it to approximate cube root of 63.5. The very first step, what is the function? Well, the operation really gives you the function cube root of, so we're going to go with cube root of x. Also, we need a number. Choose an x to be a number closest to this that we know the cube root. Obviously, the answer should be 64 because we all should know cube root of 64 is 4. Having said that, we can use the approximation. Remember, f of x plus delta x is precisely f of x plus delta y, can be approximated by f of x plus dy, where dy is f prime of x dx. And the x is the difference between the two, which is negative 0.5. 63.5 minus 64 is negative 0.5. Bear in mind, if this was, for example, 65, then 65 minus 64, let me just add an example. If you are interested in square root of 65, the x becomes positive 1 because 65 minus 64 is positive 1. So you want to be careful with that. So f of x plus delta x is f of x. We have it. Dy we don't. We have to differentiate this. So we rewrite it as x to the power of 1/3, differentiate it, and rewrite it. Dy is exactly the same thing times dx. So 1/3 cube root of x quantity squared dx. We can put the dx at top. And now we have f of x as well as dy. So having said that, cube root of 63.5 means f of 63.5 means replace the x here and here with 64 and dx with negative 0.5. Cube root of 64 is 4. And so this is 4. This one is squared at 16 times 3, 48. So plus and minus, we're going to put minus a number over 48 instead of 0.5. We're going to put 1/2. So 1/2 over 48, that means 1 times 2 times 48, which is 1/96. We use a complex number, change it to a simple fraction, and the answer is 3/95/96. Now, why did I use the decimal format also? Again, you really have to write this one. But I use the decimal format, so I'm going to put this into a calculator, and now I'm going to, so therefore, I'm going to compare and contrast. As you can see, they are extremely close. The second method is linearization. Linearization simply means find the equation of a tangent line. And I always go with the easy way out, the point slope. Now, some students write this and they may not really know what that means because they don't simplify it to write y equals mx plus b. So y minus y1 equals m times x minus x of 1. Then what is the function? F of x is cube root of x. At what point? X equals 64. So what is the pair? 64 comma 4, because if you plug in 64, you get 4. What is the slope? Into this, if I plug in 64, I get 4 squared. Remember, I got 48 here. Same thing here, 48, 1/48. y minus y1, that means y minus 4. M is 1 over 48, x minus 64. You do the math, and you put these two together by taking a common denominator. You end up with 1 over 48 times x plus 8 thirds. And now if I replace the x with 63.5, I have the final answer. Now, I highly recommend you try it and just go with the fractional format. You see you get the exact answer as we have it here. Find the absolute max and minimum function, minimum value for this function in the closed interval of -4 to 1. Let me remind you, according to extreme value or closed interval theorem, if f is continuous over a closed interval of a to b, then f has a maximum and minimum value over the interval. Here's the methodology. We're going to go over the methodology in a moment, but we are going to discuss continuity for this function. This is a polynomial function of degree 4. So recall, all functions are continuous in their entire domain. In other words, if you can write the domain, that means the function is continuous. So polynomial functions, f of x is in the form of a sub n x to the power of n all the way to a sub 0, where a sub I is real, a sub n, the leading coefficient can't be 0, and n is a whole number, 0, 1, 2, 2, 3, into infinity. Therefore, the domain is all real numbers. This is a polynomial of degree 4. The domain is also negative to positive infinity, which makes it continuous there as well as continuous in the closed interval, because this contains that. So having said that, we're going to go with the process, which is first and foremost finding the critical points. So we're going to differentiate. We get 4x cubed minus 36x. Because we want to set this equal to 0, we're going to factor the 4x and then x squared minus 9. When we set it equal to 0, we get 0, minus 3, positive 3, 3 answers. We also have to look at f prime does not exist, which gives us no solutions. Phi, no solutions. Why not? Because f prime itself is a polynomial of degree 3. So let's check. Is 0 in between? Yes. -3? Yes. +3? No. So we can use only the ones that are in between. We are going to go back to the original function and evaluate the original function f of x equals x to the power of 4 minus 18x squared at various numbers that are mentioned here, the endpoints as well as the critical points. At -4, we get -4 to the power of 4 minus 18 times -4 squared, which is, this is 16, and we end up with 256 minus 28, which is -32. If we plug in -3, we get -3 to the power of 4 minus 18 times 9, and we end up with -80. Obviously, 0 gives you 0. I hope you see that. And then 1 gives you 1 minus 18 or -17. So what's going on here? All numbers are negative except 0. So that's the absolute maximum. So we start writing. Absolute maximum is the largest value. This is the absolute minimum. The way we write it, absolute maximum is 0 at the pair 0, 0. Absolute minimum is -81 at the pair -3, -81. And you want to pay attention to the way they want you to write it. They may ask you just at x here. So pay attention to the way they ask you to do. All right, what is the integral of 3 to 4 x squared of 25 minus x squared? This is 25 minus x squared to the power of 1/2. There are two polynomials involved. 25 minus x squared is more involved and more complicated, and that's a choice option. Its derivative is -2x, therefore du is -2x dx. And we're going to rewrite this as we move x next to dx, we notice -2 is missing. -2 is a number. You can solve for dx, but the fastest and easiest way, plug in -2, undo it with its reciprocal. We're going to discuss the limits in a moment because those limits don't pertain to you, they pertain to X only. And so this is negative 1/2 remains. This is following the power rule. Square root of u goes to u to the power 1/2 to get ready for the power rule. So this part is 1 over 1/2 plus 1, u to the power 1/2 plus 1. And this is 3/2. The reciprocal is 2/3. The product is negative 1/3. You go back to original function, original limits. And I highly recommend you don't. So what should you do? I would use the lower limit. 3 squared is 9. 25 minus 9 is 16. So 16 is the new lower limit. The upper limit I put here, 4 squared is 16. 25 minus 16. 9 is the new upper limit. Evaluate it. Take the negative 1/3 out. Plug in. And 9 to the power of 3 halves is square root of 9, which is 3. Cubed is 27. 16 to the power of 3 halves is square root of 16. 4. Cubed 64. Their difference, negative 37. Their product is positive 37/3. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. So right here, we have a circular shape. The radius is R, and we know it to be 1.4 millimeters to begin. What happens, the medication causes it to get smaller. We get a new radius, which is 1.3, and the difference is dr or delta R. So R is 1.4. New R is 1.3. The difference, negative 0.1 millimeters is dr or delta R. Circular shape. And we want to use differential to approximate the change in the area. That means A equals power squared. We want dA, the shaded region, is being approximated by dA. Because f prime is dy dx and dy is f prime of x dx, I'm going to write A prime is dA dr. And therefore, dA is just like this one is A prime of r dr. And we need to use A to get to A prime first. So the ADR, pi is a coefficient, the multiplier remains, r squared becomes 2r, we get 2 pi r. So that is the derivative. So what is the A? Exactly the same thing times dr. So replace the r with 1.4 and dr with negative 0.1. And we get negative 0.28 pi millimeters squared. Very straightforward. And do not change it to a decimal unless they ask you, in which case you follow how many decimals. So you have to follow whatever they ask you. I'm showing you that one. What does it mean? The area of the cross section of the vessel is decreasing. Why is it decreasing? Because it's negative. By how much? 0.28 pi millimeters squared. Do I have to write negative here? No, because you are saying decreasing. That means that. What about the exact amount? Is called delta A. I hope you know that. I can calculate the area of the circle by using pi r squared. For the small one, I use 1.3. For the original one, I use 1.4. The difference is the exact answer. And I factor the pi out. Pi times 1.3 squared minus 1.4 squared gives you negative 0.27 pi millimeters squared. Very straightforward. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek. As seen in the diagram, find the maximum area that can be enclosed. Bear in mind, if a question like this is given, either the diagram is given to you or you must come up with the diagram because you need to define your variables, X and Y. You want to maximize the area. This is your objective function, which is x times y. The constraint, we have 240 feet of fencing. 1x, 2x, 3x, and only one y. This side doesn't need it. So 3x plus y equals 240. As always, we use the constraint to solve for one of the variables, in this case y, and we put it into a because a is a function of two variables. When we replace it, a becomes a of x. What's the difference? This is a function of two variables. This is a function of only one. X represents dimension must be positive and also must be less than 80. Because if you set this equal to 0, x becomes 80. So if it's 80, this is 0, can't be. If it's larger than 80, this is negative, it can't be. So the domain is from 0 to 80. We are going to distribute to get it ready for critical points. So we are going to go with differentiation, 240 minus 6x. In order to find the critical point, set it equal to 0, x becomes 40. So we have an open interval with only one critical point in between. Therefore, local becomes absolute. We're going to go with the first or second derivative test. We're going to go with the second because it's easier, simply a number. And as you know, you have to plug in 40 because it is independent. It makes no difference. It's always negative, means concave down, means maximum, looking like that. Now, if x is 40, 3 times that plus y is 240, which gives us y of 120. The maximum area of 40 times 120, giving us 4,800 square feet. What about fractional format? More specifically, rational. You want to simplify. How do you simplify? You factor. In this case, this is 2, this is 3. Both of them are primary prime numbers. So 2 is 2x times x, and 3 is 1 times 3. One of them has to be negative. You can easily factor it. However, the numerator cannot be factored. Therefore, the denominator is a choice of u. Its derivative is 4x plus 1, which makes the u 4x plus 1 times dx. We put the dx at top so it becomes clear we are dealing with du over u. The answer is a natural log and a constant. Replace it and keep the absolute value because the expression can be either positive or negative. However, in part B, we can also factor the numerator. Therefore, we can drop a common factor of x minus 1. We can put it in its lowest term. And we must always deal with the lowest term. Since we can't simplify it further, the denominator is a choice of u. The derivative is 2, which makes du 2 dx. Notice 4 dx is the product of 2 and 2 dx. We write it in this fashion. Now, this is du over u. The 2 outside remains, becomes a natural log. Replace it. 2 ln of absolute value of 2x plus 3 plus c is the final answer. Now, what happens if we have the reciprocal? If you have a reciprocal of this, we have to do long division. If you have a reciprocal of this, well, then we have a reciprocal of that because the common factor drops. This is half of x. This is 3/4. X itself is half of x squared. When you integrate, you get 1/4 x squared, 3/4 x, plus a constant, you're done. Let's go back to previous exams, reminding you the concept of a CTS, continuity, limit of f of x as x approaches equals f of a, and the limit exists if one-sided limits are identical. So, is g of x continuous at x equals minus 2? Why or why not? First and foremost, why are we interested at -2? Because this is a piecewise defined function. The top piece is a linear function, so is the bottom piece. Each one is continuous from negative to positive infinity. Therefore, this is continuous from -infinity to -2. This one from -2 to infinity. We're going to check the endpoint. There are three things we're going to check. The functional value, we use the equality, and we evaluate it with x minus 1, and we get -3. For the limit, we look at one-sided limits. We start with the left side, meaning less than. We plug it in here. 1/2 x plus 3 as x approaches -2 from the left. So plug in -2. This becomes -1 and 3 is 2. The right side limit uses greater than the second piece. Plug in -3. Because the left and right limits are different, the limit of g of x as x approaches -2 does not exist. And when the limit doesn't exist, can't be continuous. Therefore, g of x is not continuous at x equals -2. As far as continuity is concerned, we are really done. However, one might ask, is g of x continuous at x equals -2 from the right? Notice the functional value and the right side limits are identical. Therefore, the answer is yes, but doesn't change the fact that g is not continuous at x equals -2, but it is continuous at x equals -2 from the right. Given the graph of a function g, state the values, if they exist, of the following. We are interested in the limit of g of x as x approaches 2. Therefore, we're going to look at one-sided limits. We're going to approach 2 from the left, which puts us in this branch, which gives us this y coordinate, number 3. From the right side, puts us in this branch, brings us to this y coordinate 1. Are they identical? No, the limit of g of x as x approaches 2 does not exist. We want to do the same thing. We want to, for number 5, limit of g of x as x approaches 5, we look at one-sided limit. So approaching 5 from the left and right puts us from the left and right of this branch. Both sides bring us to the same hole, having y coordinate 2 left, right. Therefore, the limit of g of x as x approaches 5 does exist, and it is equal to 2. Also, this point is the functional value for 5. Let's say it's about 1.4. Notice g of 5 is about 1.4, which is not equal to the limit. So the limit doesn't exist. It makes it discontinuous. However, it is fixable. Remember, definition of a continuity, again, limit of f of x as x approaches a equals f of x. G of x can be continuous at x equals 5 if we redefine the functional value and make it equal to the limit. So g of 5 equals 2. So this is one of those discontinuities that can be fixed. We call it removable discontinuity. However, at 2, besides the fact that g of 2 is missing, but more importantly, the problem is it's a jump. G of 2 is undefined. It's a jump. There is nothing we can do to fix that. It's not fixable. It's not removable. What happens here, I want to remind you, when the limit of f of x as x approaches either a, or a from the left, or a from the right, is either negative or positive infinity, the line x equals a is a vertical asymptote. So we are going to look at the limit of r of x as x approaches 2. So number 2 along the x-axis, both sides take us down to negative infinity. Limit of r of x as x approaches 5. So let's approach 5 from both sides, shoots up to positive infinity. However, negative 3 from the left, the limit of r of x as x approaches negative 3 from the left goes down to negative infinity. The limit of r of x as x approaches negative 3 from the right goes up to positive infinity. All of them are classic definition of a vertical asymptote. Therefore, this one says x equals 2, this one x equals 5. Both of them say x equals negative 3. Those are the VAs or the vertical asymptotes.